We are going to look at IAL Unit 1, that is Mechanics and Materials. We had looked at Part 1, where we discussed about the multiple choice questions and the areas that you must focus on. If you have not watched Part 1, check in the description so that you can be able to get the link that is going to take you straight there. Welcome to ProfLearn YouTube channel, where we're going to have a discussion of this predicted paper of Unit 1 Physics AS. If you would like to download the paper, you can be able to check it in our Patreon page so that you can be able to access it. Let's go and let's dive in so that we can be able to get started and see what were the questions that appeared, or the areas that are quite important for you to prepare as far as this exam is concerned. The first section we talked about, Part 1, was multiple choice, and this paper usually have multiple choice section, question 1 to 10, and now the rest of the questions will be structured questions, and that is exactly what we are going to focus in this particular tutorial. If you are new here, subscribe, and also just consider sharing this video to your friends. Encourage them to join ProfLearn YouTube channel. We'll be doing more tutorials thereafter for Unit 2, Unit 3, Unit 4, and also Unit 5. So just find a reason to subscribe so that anytime I'll be doing more tutorials, you'll be notified. Let's dive in so that we can be able to get started with question number 11. The most common question that is going to be tested is Stokes law. And you're going to realize that Stokes law is going to apply, and Stokes law is going to hold provided a few conditions are met. Number one is that the flow must be laminar, should be streamlined, should not be turbulent. The sphere should be small and moving at a low speed. The sphere should be spherical and smooth. The moment that you are going to have a rough type of sphere, it means you are going to have a turbulent flow, and that is going to affect that motion. We must also ensure that the sphere does not really touch the walls, and in the process, because if it touches the walls, it's going to tamper with the motion, and the motion may be turbulent because the sphere may start spinning also. The process turbulent flow is going to be enhanced. Another concept also you must understand is the concept of terminal velocity. You need to understand the definition and how terminal velocity condition apply. So one of the concepts that we're going to say here is that terminal velocity is achieved when upthrust force plus drag balance are balanced by the weight. So what does that mean? If an object is falling through a fluid, this object is going to experience different forces. One of the forces is the downward force, which is the weight, and the upward one of the upward force is drag force, the resistance due to the fluid, and also upthrust force, because we know that when an object is placed in a fluid or in a liquid, is going to displace some liquid, and that liquid displaced is the equivalent to the upthrust this object is going to experience. So in that case, for upthrust, for terminal velocity to be attained, upthrust plus drag should be equal to the weight of the object. So that means that the resistance, the resultant force will be 0. Now, if you are asked to draw, you should draw these two diagrams in such a way that if you add the length of this should equal to the length of the weight downwards. So that's also something that you need to understand. We have another question, and this question is testing about deducing whether the liquid she used was glycerol. And the way we are going to approach this is to ensure we are working out, we are trying to work out the viscosity, yeah, and we work out this value of eta here so that we can be able to check, does it correspond to the value that is given for viscosity for glycerol. So the moment we realize that they are equal, all they agree, then we can be able to say then that liquid is glycerol, because we understand different liquids have got unique difference of viscosity. So how do you work out this? The first thing you are going to do, because let's check the information provided. A student thought that the liquid she used might be glycerol. She made measurements and to determine terminal velocity, bearing, and then the terminal velocity of the ball bearing was considered to be this. Deduce whether the liquid she used was glycerol. So we are given density of glycerol, we are given the radius of the ball bearing that is passing through that liquid. Then we have the weight of the ball bearing, then we have viscosity. So the first thing we are going to do is to work out the volume. And the moment we have worked out the volume here, we are going to use that volume of the sphere to know the volume of glycerol that was displaced. All right, so that you can be able to apply the formula mass of glycerol is equals to density of glycerol times the volume of glycerol that was displaced, and this volume that was displaced is equivalent to the volume of the sphere. Now if you work it out, you're gonna get it to be 6.43 times 10 raised to the power negative 5 kg. So that is the mass of glycerol. Then remember, this sphere is going to experience what we call upthrust force, and upthrust, the amount of upthrust force this is going to experience is equal to the weight of glycerol that was displaced. So in that case, we shall use, you can see we are using this value that we have gotten here as the mass, and in order to get the upthrust, now we can be able to work it out here, because upthrust is equal to the weight of the liquid displaced. Now once we have gotten this, we shall go ahead now to calculate drag, because we had said here that weight is equals to upthrust plus drag. So meaning drag is going to be equals to weight minus upthrust, and yet upthrust we have gotten it here. So we shall go there and then do the subtraction, and we shall get drag now is equivalent to this. Now that's the point we are going to use Stokes law. And remember, Stokes law is a law that enables you to work out drag experienced by an object when it's passing through a fluid. Now in this case, you realize that Stokes law is equals to 6 pi viscosity times the radius of the sphere times the speed at which that sphere is moving, and that is actually the terminal velocity that we are having at this point. This is going to represent the terminal velocity. So if we now make eta all viscosity subject, we're going to get this as 0.94 pascals second. And you now go and check the value that was given here. You can see now the values are actually they are a bit close, so which means that we can now attest that that liquid was generally glycerol, because the value you have obtained is very close to the value of viscosity that was provided for that. Moving to question number 12, and number 12 is basically Stokes law, and because most of the time some students find difficulty in this question, that's why I decided that this question will be frequently appearing here, so that you'll get used to, you know, how to go about different questions when they are asked within this. You can see now we have again the condition. Then we shall now move to another question that says the bubble moves upwards at a constant velocity. The volume of the bubble is 5.3 times 10 raised to the power negative 11 show that the upthrust of the bubble is about that. So we are going to say upthrust is equal to the weight of the fluid displaced. Yeah, so in that case, upthrust is going to be weight of the liquid displaced, and liquid displaced, the volume of the liquid displaced is equal to the volume of the bubble itself. So if you work it out, you're going to get your answer equivalent to 5 times 10 raised to the power negative 7 newtons. The bubble moves upwards at a constant velocity. Deduce whether Stokes law applies to this bubble, and we're going to ignore the weight of the bubble because the bubble is it has a very small amount of weight. So we are going to assume it to be 0 when we are doing this particular calculation. So we can be able to conclude and say drag is equals to upthrust. All right. So if you do that, you're gonna get drag is equals to upthrust, and upthrust was 5 times 10 raised to the power negative 7. We had gotten it from the previous section. Now we are going to use this value that we have here, and then we need also to find the radius. Yeah, so we need to find the radius, because in the process of working out or checking out whether Stokes law applies, we're going to use this formula here, that drag force is equals to this. So we need the value of viscosity, we need the radius, we need the speed at which it's moving. So going to check using that. So that's why you can see at this level, I decided to ensure that I'm getting the radius here, which is going to be 2.33 times 10 raised to the power negative 4 meters. Then we can now apply that Stokes law formula at this level, at this point, and this is going to be what? This is going to be 1.46 times 10 raised to the power negative 7. So if you look at this value that we have gotten, is very less than, is quite less than the drag that we had gotten here. Remember, our drag was this value that we have here. So you see those two values are really, there's a very big discrepancy. So that comparison will tell us that drag will be too small, so it will not be able to balance with the upthrust, and in that case we have deduced that Stokes law does not apply here. Stokes law does not apply. Moving to question number 13, and you need to understand a question to do with motion in inclined plane. And also you'll have to look at what is the main purpose of that inclined plane, because you can be able to use an inclined plane by lifting objects. You are hanging a mass here so that it can be able to pull an object to raise it over some height. Yeah, because if maybe you want to load a heavy object to a truck, you cannot be able to lift that object directly there. You may need an inclined plane so that you can be able to lift it, raise it easily. So you realize that the useful form of energy in this particular question here is converting that energy to gravitational potential energy. So useful work done is equals to mgh, which is going to be mass of the object that is being brought up the inclined plane times the height of which is going to rise, and that is the height that is going to rise here. So if you work it out, you're going to get mgh to be 9881 joules. Input work done is the work done to move this along the inclined plane. So the work done to move it along this particular distance is the input work done. So you realize that the distance over which this object is going to move along the inclined plane is going to be 15 meters. So remember, work is equals to force times distance, isn't it? So in that way also, what is the force that is applied along the inclined plane here? That force that is applied is equals to the weight of this particular mass that is hung. So the tension of the spring in this side and the tension of the spring in this of the string in this particular side, they are what? They are equal. So which means the force that this is going to be pulled up the inclined plane is equals to the weight of the mass that is hung here. So that's why you can see I worked out the weight of that particular mass, and then I went ahead to use that as the force that is pulling it up the inclined plane. And now you can also agree with me that the distance over which that is going to be moved is 15 meters. So a force of 78.48 is applied along the inclined plane of 15 meters. So the input work done was equivalent to 1177.2 meters. So that is the input work done. So also now you need to remember the concept of efficiency. Efficiency is given by useful work done divided by the total work input. So if you work it out, you are going to get is about 83%, which is a bit less than 90. So that is, I think, what you are supposed to determine whether the maximum efficiency of the machine is greater than 90. So you are going to be asked question to deduce, you are going to be asked question to confirm, something like this. So that is the kind of the way you could have approached such kind of questions. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. In ProfLearn YouTube channel, we do maths and physics, pure math, and physics up to Unity 5. So if you are new here, consider subscribing and also encourage some of your friends to join us so that we can be able to grow the channel together. So let's dive in and get started in question number 14. Question number 14 is the question to do with projectile motion, whereby you are having a projectile motion that is acting at an angle. Guys, this is a question that you cannot miss. You will not miss such a question in an exam. Yeah, so you can see it's projected at 25 degrees at an angle of 25 degrees at 35 meters per second. So the first thing that you need to work out is the vertical and horizontal components. So if you work out the vertical and horizontal component, you'll find that this horizontal component is going to be 35 cos 25. Vertical component is going to be 35 sin 25. So if you work it out, you are going to get these values here. And once you have those values, you can be able to work out now how high an object moves. Whenever you're working out the height, motion in the vertical direction, you use the vertical component. When you are working out motion in the horizontal direction, you use the horizontal components. And that is the reason as to why we are working out these components so that we can be able to go ahead and use them. And if you want to find how far the object is going to move in the horizontal direction, you use the horizontal components. But what is usually the same for motion in the vertical and the vertical and the horizontal component is the time taken. Maybe the time taken for this particular object to move from here to land. Maybe let me just draw it properly. Time taken for this rider to jump from the ramp all the way to the end there is the same time taken to move along that particular distance of 100 meters. And usually this is usually called the range. So the range is usually initial velocity in the vertical direction times the time taken. Yeah, and time taken for this particular distance, you are going to use maybe s is equals to ut plus this case, because initially when it started moving, it's moving vertically up, so we shall use minus a half gt squared. So, and in this case, the initial velocity you're going to use is the velocity in the y direction, or the vertical component. So don't confuse the use of this. Vertical component is used to evaluate motion in the horizontal and the vertical trajectory, and the horizontal component is used to evaluate or determine motion in the x direction. So deduce whether the rider lands on the other side of the river, and we are going to ignore the effect of air resistance. So the first thing that we need to do is to know the time taken. So we can be able to use this the distance that we have here, so and the velocity in the horizontal component, to know how long this person is going to take to cover this distance, which will be the same distance at the same speed to cover here. So at that point, we're going to say time to travel horizontally is going to be 100 divided by 31.7, which is going to translate to 3.15. Vertical displacement, the vertical displacement in that time, in the same time, and we are saying time taken to cover horizontal particular okay, is the same time that we have here, we shall use. So we can be able to say now, find the height of the rider in that particular period. So you realize that if you substitute it into ut minus half gt squared, the time is going to be, the distance traveled will be negative 2.1, which means that is a height below the point where this person was taking a jump from. So during that time, the distance above the ground is going to be 0.9. So which means that since we can see the value we are getting, we can even as well say 3.0 is actually greater than 2.1, then this means that the person is going to land on the other side. This person is going to land on the other side of the river. Explain how air resistance is going to affect the jump. Air resistance is going to oppose motion in the horizontal direction, and this is going to reduce the time, so the horizontal distance traveled also decreases. So that also we're going to consider that. Now another concept that you really need to understand at this point, you need to understand the concept of force is equals to mass times acceleration, which is actually Newton's second law of motion. So we are told that the mass of the car is 1850. Some people sits in the car, and the car then accelerates at 0.23 meters per second square. The resultant force on the car is this. So we are going to use the resultant force and the acceleration that is provided, so that we can be able to get the mass. And once you have the mass, you can go ahead now to work out the mass of the passengers, or the mass of the people inside there, because we know the mass of the car plus the mass of our people is going to add up to 2000. So we have to subtract and get that value. We have also a question to do with momentum. Under momentum, you need to know how to calculate momentum, how to calculate impulse, and you need also to understand the law of conservation of momentum. And in this case, we need to understand that momentum before collision is equals to momentum after collision, provided no external force act. And momentum, you need to understand that the momentum is a vector quantity which is calculated by mass times velocity. But what about impulse? Impulse is Ft, force times time of impact, and also impulse is equals to the change of momentum. So in that case, we need to look at calculate the mass of the sphere. We are given here a Newton cradle, which has 5 identical steel spheres A, B, C, D, and E, each hangs on string as shown here. Each sphere has radius 7.0 times 10⁻³ . Calculate the mass of one sphere. Given that the density is this, you can be able to use density is equals to mass of volume. Then once you have that, you can be able to go ahead and work out the mass using this formula here. So how do we get volume of a sphere? Volume of a sphere is given by 4/3 pi r cubed. So areas that you need to check out in this question is checking and confirming if the measurements that were given here, whether the measurements are in meters, and also you need to check if the dimensions you are given, is it radius or is it diameter? If it's diameter, you have to divide. So don't go and make mistakes of not checking the measurement, the units of measurement, and also whether it's a diameter or radius. So that's where most students get it wrong. So once you work out the volume, we're gonna get it like this, and then we can now say mass is equal to density times volume, which we are going to get as 1.12 times 10⁻⁻² kilograms. If they want you to find the weight, well and good, you can be able to go ahead and do that. We are having now, you can see now that one of the sphere is just displaced, and once it's displaced, you see at maybe at a small angle, it's displaced at a small angle, then it's going to have an angle here, then it will be moving. So the moment it moves, it's going to collide with this, and the momentum is going to be transferred. All this will be static, then you will find that this one is the one that is going to rise and move. It's quite interesting concepts that usually appear. And determine the initial acceleration of the sphere. Now, in order to find the initial acceleration of the sphere, you're gonna realize that if this angle is 38, also this angle that we shall have here is going to be 38. That's just use of trigonometry. Therefore, the component of weight in the direction of motion is going to be W sine 38. Yeah. So having that, we can now go ahead and work out that force, because W is equals to mass times gravity times sine 38. If you work it out, you are going to get your answer well seated here, 0.0676 newtons. And then once you have gotten that, you can now apply the concept of force is equals to mass times acceleration for you to get that particular value, acceleration, to be 6.04 times 10 meters per second square. Going ahead now to the next part, you'll be seeing questions like this with stars. This means that this question will be marked in such a way that marks will be awarded if you are able to articulate your points in a procedural manner, well organized, and step by step until you get the answer you get the conclusion they are asking. So you have to ensure that you must write your answer in a procedural way for you to earn marks at this point. So let's see how you can answer such a question. Now let's look at diagram 1. Shows position of the sphere when A is released. So this is displaced, is going to swing down, then it will collide with B, then B, once it collide with B, its momentum will be transferred to B, then transferred all the way to E. All this will be static, then this one will move away. So that's what they are saying. After being released, sphere A collides with sphere B, comes to rest. Sphere B and C remains at rest. Sphere E moves away from sphere D. All right. Diagram 2 shows the position of the sphere when E reaches the highest point. So also we have different conversion or transfers of energies taking place. When A is released from the highest point, is having maximum potential energy, so which means that the moment is going to be released so that it starts swinging down, is going to convert the gravitational potential energy to kinetic energy. So at the highest point A, it has maximum potential energy. As it swings down, the potential energy will be converted to kinetic energy. So kinetic energy will be increasing as potential energy will be decreasing. So the moment it collides, because it's having momentum, it's going to transfer its momentum to B, to C, to D. Then D, at D, all the momentum will be converted to E. So meaning now, any object that is having momentum will be in motion. So the moment E absorbs all the momentum, is going to start moving, because momentum is a property of moving object, and moving object has momentum. So since E will get the momentum, then it will start to move. So it will start to rise until it reaches the maximum height. So as it's rising, its kinetic energy will be decreasing as the gravitational potential energy will be increasing until it reaches the maximum height. So basically that's what you need to understand at that given point. But now let's see how you are going to give the answer. Describe the changes of energy and momentum of sphere A and E, the time from the time sphere A is released until sphere E reaches the maximum point. So you have to ensure that you are going to articulate your answer in such a procedural way that the examiner is going to award you all the 6 marks. Now, we are going to start from A, and we're going to say sphere A is, when sphere A is released, it is gravitational potential energy. Its gravitational potential energy decreases, and its kinetic energy and momentum increases as it swings down. As it swings down, potential energy will be decreasing, but kinetic and momentum will be increasing. During collision, momentum is conserved. So sphere A transfers its momentum through the stationary spheres to E. So E moves away. Then sphere E rises, converting kinetic energy to gravitational potential energy, and its momentum decreases to 0 as it rises to the highest point. Ignoring air resistance, then we can be able to say now the law of conservation of energy applies, that energy remains constant. So that is how you're gonna explain those star equations. Moving to question number 17. Question number 17 is talking about gravitational potential energy of a train that is moving up an inclined plane. So what you need to understand here, gravitational potential energy is equals to mgh. So we are going to do the question as shown at this point here. The train's engine has a output power of 20 megawatts and the train takes time of 35 seconds. So this particular question, the examiner wanted you to get the total work done, and the total work done is power times time, but remember it's megawatts, so that is going to be multiplied to 10 raised to power 6. Don't forget that. And if you work it out, you're gonna get your answer equivalent to 7 times 10 raised to power 8 joules. Now, work done against air resistance will be the input power minus the useful power that was done. The useful work done, what I'm saying is that work done against air resistance is equal to the total power supplied, or the total work done minus the useful work that was done. So in that case, we're going to have 7 times 10 to the power 8 minus 4.17 times 10 to the power 8, which is going to translate to 2.83 times 10 to the power 8 joules. That was done against. So another type of projectile motion that you can be tested is whereby an object, a stone or an object is projected horizontally, not at an angle. Projected at an angle, we have done it. But now horizontal projection, also that is what we are going to look at. So something that we need to understand, calculate the horizontal distance from the bottom of the cliff to where the stone is going to land. Because the object is going to follow that trajectory, what we need to understand, the time that the stone takes to cover this particular height is the same time it's going to cover the range in that particular direction. So what we also need to put in mind, in vertical direction, the distance that's going to be covered in the vertical direction, distance that is going to be covered is going to be 12 meters. But when by the time of projection, when the stone is being projected horizontally, this stone was not moving downwards. The stone was projected horizontally. So meaning the vertical motion of the stone in the point of projection is 0. So that is what we need to understand, that initial velocity in the y direction in the time of projection from the top of the cliff is going to be taken to be 0. So that is why now we are going to say ut plus a half gt squared. So this term will disappear because initial velocity of this stone during the time of projection was 0, because the object was projected directly horizontal. But if in the case of projection at an angle, you will realize that there will be vertical motion, and that is the vertical component. So here we are going to use this equation so that we get the time it takes the stone to cover this height, and if you work it out, you are going to get it to be 1.56 seconds. And then you use the same time to calculate the range, because the object in the horizontal direction will be moving at a constant speed. So the constant speed, this speed will not be changing in the horizontal direction, because every time this object will be moving at the same speed in the horizontal direction, as the speed will be increasing vertical downward, but the horizontal speed will remain constant. So we are going to say the and range is equals to u in the x direction, which was 38, times 1.56, the time that we have gotten here, which is going to translate to 5.9 meters. Yeah, so time to cover this height is the same time taken for it to move in the horizontal direction. Next also, you need to have a good understanding of the concept of you need to have a good understanding on the concept of moment of force. And moment of force, you need to understand that moment is a turning effect of a force, and that moment is going to be calculated from the point of action of the force to where the distance from the point of action, the perpendicular distance from the point of action to where the pivot is. So here we are told about a rolly that is crossing a bridge, and the bridge is supported by 2 columns as shown here. They are this column 1 and column 2, and then force P and Q acts on the bridge from the columns as shown on this diagram. The bridge has its center at X, so this is where maybe you can consider where our X is. Now calculate the magnitude of the forces P and Q, and you should take moments about X. So we know that when you're taking moments about a given point, we can now say that clockwise moment is equals to anti-clockwise moments. All right, so in that case, we are going to say total clockwise moment about x will be about s clockwise moment. So if it will be here, the roll will be pushing down here. A moment that is going to be in this direction is clockwise moment. So the distance from where the pivot P is to this, we're going to use the force of the rolling. And the distance from where the pivot is to this, we're going to use the weight of the bridge. So that's why we did 4.2. Remember, 4.2 is the weight of the rolling times 35, because the distance from where the pivot is to that particular point is going to be 35, then plus 9.8 times 10 raised to the power 5 times 60, because from here to this particular point, 35 plus 25 gives us a moment due to the weight is going to be from where x is to the turning. So that's going to be 7.35 times 10 raised to the power 7 Newton meter. Anti-clockwise moment will be provided, because when these forces will be pulling down, this Q will provide anti-clockwise moment. So we have to consider the distance from where P is to where Q is, so that we can be able to get that one also. So we are going to say the force we assume is to be Q times 120, because from here to here is 120. And if you work it out for Q, we are going now to use the principle of moments. Clockwise moment is equal to anti-clockwise moment. If you work it out, you are going to get your value to be 6.12 times 10 raised to the power 5. But at equilibrium, sum of downward forces should be equal to the sum of upward forces. So since we know what Q is, and we know the weight of the bridge and the weight of the rolling, we are going to say sum of downward forces should be equal to the sum of upward forces. So we are going to add the weight of the bridge plus the weight of the rolling should be equals to P plus the value of Q that we have gotten. So if you do that, you are going to get 7.88 times 10 raised to power 5 in that case. So if you have gotten value, let me know in the comment section whether you understood how to go about this question. And also you just leave a comment down below. Let me know which is the topic that you really felt that this topic I've understood it so much than I really that I've understood it better, and I'm now a better student than I when I came to this particular channel. And also guys, subscribe and also share my channel to your friends, encourage them to join us. The next question that we are going to look at here, you are told to explain why force Q increases as the rolling moves across the bridge. So you realize that as the rolling moves away from X, then the moment about X increases. Since distance remain the same, then the force has to be greater. So that's why I wrote the answer here and said as the rolling moves away from X, the moment about X increases to maintain rotational equilibrium. The anti-clockwise moment about Q must increase, and since the perpendicular distance is fixed, is not changing, then the force must also what? The force must also increase. Yeah. Moving to question number 20 rather. This is a question that is testing the conservation of momentum, how you are supposed to state momentum, and this one is very, very important for you to understand how to state the law of conservation of momentum, because that question might be asked. And since we have said that momentum before collision is equal to momentum after collision, then we can be able to work out question like this. We are asked to deduce whether momentum is conserved in this collision. So skater B, this person skater B is moving at a higher speed than skater A. So they are going to collide, and the moment they are colliding, they'll now move at the same speed together. So we can be able to check whether momentum is conserved by confirming the value for momentum before collision. And how are we going to get the momentum before collision of these guys? Momentum before collision will be the momentum of skater A plus the momentum of skater B. Yeah, so you add them together. After collision, they are going to move together as one body. So meaning you will need to add their masses and then times the speed at which they are moving together. And that is exactly what I did here. I worked out momentum before collision, which I got to be 60 times 7.5 plus 65 times 5.5. And if I got 807 Newton per second. Then momentum after collision, I decided to add the masses because they are going to combine and they move together at the same speed. So that's why I just added them together. Then I times the speed at which they're going to move, and that's going to be 775 Newton second. So you can see here, momentum is not conserved. And because the values are a bit different. So why do you think momentum is not conserved? Why is it that momentum is not conserved? Why is it that momentum is not conserved? Reason, just write in the comment section. Why do you think momentum is not conserved? So remember, the law of conservation of momentum states momentum before should be equal to momentum after, provided there's no external force act. So provided the system is closed, no force that is going to come into the system. Now in this case, we are having air, we have air resistance, we have friction force. So this is going to really affect the motion. So in that way, momentum is not going to be conserved. So write in the comment section, why is momentum not conserved? What can contribute for momentum not to be conserved in this case? Next, we need to look at we need to explain the decrease in kinetic energy after collision. So we can say kinetic energy occurs because decrease of kinetic energy occurs because work is done against friction between the skates and the ice, and this is going to convert kinetic energy into thermal energy. So that is what we are supposed to do in that particular question. Question 21 was looking at a ratio between motion of objects on Mars and on Earth. So in order to work out that, I used v squared is equal to u squared plus 2s. But since we were told that from rest, the object was falling from rest, so meaning that initial speed was 0, so meaning that this equation is going to remain this way. So if you want to work out v squared, you'll have just to use 2gs, 2 times gravity times the distance which is denoted as s here. So once you've done the correct substitution, don't forget to find the square root of this, and if you work it out, you're going to get 0.62 as a velocity ratio of velocity in mass over velocity on Earth. And then we still have a question to do with Stokes, and I think this is quite appeared most frequently, and I'll give the reason is that most students really struggle with this area, and I believe now by the time you have finished this paper, you will be in a position to answer most questions. Give one measurement in the process of finding terminal velocity. You need to find the mass of the ball bearing, and that mass of the ball bearing is going to enable you maybe to work out the weight so that you know what the weight is. So some of the measurements, that the diameter of a ball bearing, so you can see you are given a diameter and also it's in millimeters, so that one has to be converted to radius and has to be given in meters, and that's exactly what I did at this level. If you make a mistake, you don't do that, you're gonna get the question wrong, you start crying after coming out of the exam room. So anytime you're doing physics question, ensure that you check the measurements given and the correct unit so that you do the correct thing. That is the main purpose as to why I created this video for prof learners. Prof learners don't make mistakes when it comes to units, when it comes to conversions. Prof learners don't do that. Make sure your eye is wide open so that anytime you are doing the exam, you are alert, so that you can be able to avoid these potholes that may make you fail. So you ensure that you are safe. We have to ensure that safety is guaranteed when you are doing an exam, and our safety is based on the units. Now, once you have gotten the radius, you can now apply Stokes law, and remember, is drag force is equals to 6 pi viscosity times the radius times the terminal velocity. But since we are calculating the viscosity of oil, we are going to make it the subject. And if we do that, you can see the value that we are getting here. If we work it out, we put it in the calculator, we are going to get it what? Our viscosity to be 0.031. Yeah. So that is what we are going to get as our answer in that case. The student repeated the experiment. He used the same oil at a lower temperature. So if temperature decreases, viscosity increases. So when viscosity increases, so you can see this formula that we have at this point. This is Stokes law. Drag, because F is drag experienced by an object, and the drag is equal to 6 pi viscosity times R times terminal velocity. So meaning if F decreases, V will decrease. If F decreases, V will decrease. If F increases, V is going to increase, because they are directly proportional. So in that case, we're going to say at lower temperature, viscosity of oil is going to increase. This increases the viscous drag. So if viscous drag increases, also V is going to increase. So, and just move this now, which means that this viscous drag, as the increases the viscous drag, if viscous drag increases, reduces terminal velocity, and therefore time taken to fall is going to increase. Yeah, so that's the logic behind this particular question. You can be able to check there. So let's move at the law of flotation. And when objects are floating, in fluids, something that we need to put into consideration is that an object displaces its own weight. Calculate the weight of the block ice. So we started by working out the volume, because we were given cross-section area. So we are supposed to work 6.7 times that cross-section area, so that we have the volume. And that volume is equal to the volume of the block, which is equal to the volume of the liquid displaced. So mass of liquid displaced will be equals to density times volume. Yeah, because the volume of the object in a liquid is going to displace the same volume of the liquid. So if we want to find the mass of the liquid and the seawater here, that is going to be the density of seawater times the volume that we have gotten in the previous section, which is going to be 3.415 times 10 raised to the power 7. Now, weight of the iceberg is equal to the weight of the liquid it displaces. So this is going to be equivalent to 2.37 times 10 raised to the power 8. And that is going to be equals to 2.37 times raised to the power 8 newtons, because the mass you get here, because we understand that weight is equals to mass times gravitational field strength. So if you work it out, you're going to get your beautiful answer there for that particular section. An identical block of ice floats in water of lower density. So if it floats on water of lower density, so it means it's going to experience less upthrust. So it has to sink further so that it can be able to displace more water. Yeah, so that is exactly what we're going to say here. For an object to float, remember upthrust must be equal to the weight. Now for lower density fluid, to provide the same upthrust, then more liquid has to be displaced, and that is achieved by the block sinking deeper. So that is why mostly when a ship is moving from fresh water, it's moving from salt water to fresh water, it has to sink deeper because fresh water has less density than salt water. So that is the logic behind there. Let's move to question 24. Violin and instrument. So the moment you start hearing this, tension is coming in. Then Hooke's law will start working in. Now, the graph of force against extension gives a straight line for a material that obeys Hooke's law. And in that way, this graph is going to enable you find the stiffness or the spring constant. Where the region where the graph is straight, it means the extension is directly proportional to the force applied. And this region, the material obeys Hooke's law. So if they are asking you to find, deduce which string was used, basically every material has got its own spring constant, so all stiffness. So then meaning that we are supposed to work out here the gradient and check with this which one is corresponding to that. Another concept that you must take quite seriously is the calculations of Young's modulus, whereby we understand that Young's modulus is equal to stress over strain. Because you are stressed for these coming exams, then you are straining for you to prepare for the exam. So Young's modulus is a property of material. So we're going to say stress over strain, but stress is force exerted on the material over their area in contact, or the cross-section area, which is going to be having the units of pressure. Stress has the units of pressure. Strain is the extension of the original length. So if we are going to combine these two equations together, we are going to have this. Young's modulus is equals to force times original length of the material over cross-section area times the extension. And I've identified those quantities here for our safety purposes. All right, so extension, remember, is calculated from new length minus the original length when an object has been stretched. So it has, we have to do that. So based on the information provided in the question, now we can be able to substitute, and you are going to get 6.0 gigapascals, which is the same as 10 raised to power 9 gigapascals. Guys, if you're new to ProfLearn YouTube channel, just subscribe. If you're new here, just subscribe. Leave a comment down below if you've really gotten value from this particular tutorial. Just take a moment to subscribe, and also share this video to guys who are doing physics, and even those who are not doing physics, because we already have predictions for pure math and other subjects here. And also you can even share to the Cambridge guys, because there are some tutorials for IGCSE Cambridge, A-level Cambridge, also in this particular channel. So let's dive in, and we move to question 25. Question 25, we are told a student carried out an experiment to determine the viscosity of a liquid from graphs. Now physicals from graphs. Explain what's meant by terminal velocity. We are going to say this is the maximum constant maximum velocity reached by an object that is falling through or moving through a fluid, and that happens when the weight balances with upthrust and drag. So that is how you can be able to define that. And then we are told that a glass sphere of diameter 35 millimeters. So we said that you have to look at this as if your life depends on it. And terminal velocity, we have the density of glass and density of the liquid here. Now, show that the drag is about this. So meaning we are going to work out the volume. And once we have worked out the volume, we can be able to calculate the upthrust. And upthrust is equal to the density of the liquid times the volume of the sphere. Because the sphere will display the same amount of volume of the liquid times gravity, which is going to be 1.43 times 10 to the power 3 times 2.24 times 10 to the power -5 times 9.8. So we're gonna get the weight of the liquid displaced, which is going to be equal to the upthrust. Then the weight of the sphere will be the density of glass of that material times the volume times gravity of 9.81. So if you work it out, you get that. Therefore, now drag, remember drag plus upthrust is equals to weight. So if you want to find drag, is the weight minus upthrust. And if you work it out, you're going to get 0.24, approximately 0.2 newtons, which is exactly what we were supposed to show here. The student reads in a textbook that Stokes law is equals to V is equals to KD squared. Yeah, so V is equals to KD squared. So you can see it's the same graph that has been plotted, V against D squared. So meaning that we can be able to say V is equals to KD squared plus 0 because this line is passing through the origin. So the intercept is 0, y-intercept is 0. So meaning that this equation can be related with y is equals to mx plus c. And in that way, k is going to correspond to the gradient here. So meaning if you go back to the graph and work out the gradient, it will be equivalent to the value of k. And I just used this section of the graph here. So I worked out the gradient because gradient is rise over run. Don't forget these quantities that are usually on the graph, guys. This is where students get it messy. It gets messy when you your eyes are not wide open. So when you work out the gradient, you're gonna get the gradient being 6.0, and so that is the value of k that we were being asked. And then we are told that the constant k is given by that, where this eta is the viscosity of the liquid, determine the value of n. So we are just doing substitution with the correct value that we have gotten from the previous question for k, and we do the substitution here, and our viscosity is going to be 99.0 Pascal second. If you are new to ProfLearn, guys, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next tutorial. And also, good luck to you in your exams. Remember to come back and tell me how many topics, how many concepts that we have discussed in this particular video appeared in your exam. Good luck, you guys.